Good day everybody and welcome back. What I got is a piston out of a hydraulic cylinder that I'm going to attempt to make another one. This one's all the threads been marred up because I didn't realise there was a couple of set screws under the seal and they don't come undone when they're not undone. I have had a pretty good look at it and I reckon I can build it pretty much in one setup on the lathe. Like do all the internals and all the externals. There'll be only on the mill to put these two flats on and very gingerly chuck it back up just to skim it this face once I've parted it off. So that's what we're going to attempt to have a crack at. Should be a bit of fun. So I've gone ahead and chucked up a bit of material in the lathe and roughed it down and faced it off, roughed it down, just to save a bit of time with the filming, that's all. So anyway, we'll go over to the lathe and see if I can do this. Okay, I'm going to get the OD down to a final dimension, which is the biggest diameter is 62.44. So I've measured that quite a few times. So this diameter and this thin diameter here measures 62.44, which is an odd size I reckon, but that's what it measures. So once I do that, then I might concentrate on doing all this center, the center bore and the thread, and then if I screw that thread up, then I haven't wasted a heap of time doing the outside. So $64.02. Bad, 62.44. The other day I received a tool in the mail from England, so made by Linn. So it's got magnets that it attaches to the tailstock, and you can put it any angle you like. And that just lines up, you do it up. I like to put it out on the end of the tail, on the end of the quill. Bit out of camera there, eh? And then the beauty of this, you can have it wherever you like. I like that. It's not just sitting up the top. When you're short like me, you can have it tilted over and be able to do holes accurately to accurate depth. And I was fiddling around with it the other day, and it turns off in about 3 or 4 minutes, I think, or 5 minutes. So it doesn't matter if you forget to turn it off, it just turns off by itself. You know, it's going to be a handy thing to have, I reckon. You can still eject the tool, because I've just always relied on the graduations on the quill itself. So now I can actually drill some accurate depths. What I reckon I'll do now is I'm going to drill a hole all the way through, and then bore it to the dimension for the 36mm thread, and then we'll do the 40mm bore after that, and I'll thread it. So if I screw this up, this threading part of it, then I haven't wasted a heap of time doing the outside, which I could screw that up too. I'm going to run this 1.5 inch. What is it? I can't remember what size this drill was. 1.5 64ths. I'll run that through and then set up for the boring bar, but that'll probably be in the morning because I'll probably get roared at in a minute for not being inside having me dinner. That is at 30.01 at the moment, that bore. It has to go out to 33.9 for the thread. Then we have another bore to do on this end here. Just going to gnaw away at it. It's interesting, like I know I'm boring miles too deep, probably 45mm too deep, but it's interesting to see how this bar behaves over the longer distance as it's getting bigger. So that's the idea behind that. I just want to see what this bar will do. So I'm shooting for 33.9. A couple more cuts and I'll be out there, so I'll bring you back when I'm on the last cut. Absolutely beautiful finish. Nice. I'll bring you around and show you that. 33.905. Hope you can read that. It's not bad. What I'm thinking about doing is, when I cut this thread, that's 50mm long, and coming in say 55, 56, whatever mil, and then relieving that section so the boring bar's got something, or the threading bar's got something to run into. A heap of sirens going on here. Don't hear that very often around here. Yeah, so that part is 50.5 long. So I'm going to come in 60, around about there, and then just relieve it a bit so when I cut that thread, yeah, it makes it a bit easier. Just have to watch that bar didn't rub up against the side of the wall there. So now what I'll do, I will put that 40mm bore in. So 40mm bore, 20mm deep. I'm not going to worry about shorting that bar up. It seems to be running fine where it is, and his DRA is already set, so. It should be 40mm on the money. Should. $39.99. There also has to be a groove put inside this 40mm bore for an O-ring. The old one's it's a square edge on the old one, square edge groove, so let's make it the same. Anyway, I am wondering whether I do that first and then thread it, or do the threading first and then do that. So I don't know. Have a cup of tea and think about it. Okay, I've decided to put this groove in, and to measure it, to measure the depth of the groove, I just use a set of dividers, and it works out that it's 45mm diameter and 6mm in from this face, and the slot's 7mm wide. I've never used one of these grooving tools like this, so it's all going to be trial and error, just going to take me time. That's why I thought I'd do this now, so if I do screw up, then yeah, you know what it's like. And I've got no idea what spindle speed to run these tools at. I'm just going to double check that centre height. I reckon I may have it a fraction high. Like I say, I've never used one of these grooving tools. I've only just bought it, and the only reason I bought it was it came with a box of 10 inserts, and I needed inserts for the grooving tool anyway. So I thought, oh, I'll just grab a new bar. It's only a cheap import one, so it's probably lucky I've even got it. I can just hear it touching the caliper. That's at 44.98, so I'm going to leave it right alone. I'm going to get set up to do the thread now, and while I've got the threading bar in, I'll just break the edge on that groove slightly, just with the threading bar. Okay, I've jigged up another light. I just want to go in here and break these edges. That'll do. Okay, Fair bit of stick out on the tool, but we're going to give it a crack and see what happens. Might just put you guys on a time lapse because it's going to take a while. Eh? Just a fraction tight still. I'm just going to take one more pass. I'm going to call that good. Nice. This, sorry about the mower in the background, but I ain't going to stop the missus from mowing the lawn. This edge here has to be radiused, just a nice radius by eye. It's only a bit of a cosmetic thing really, and you've got to have a shoulder put on this 1/2 mm shoulder on this outer ring, and then I can start all the external dimensions. Okay, we'll put this 1/2 mm recess in. Okay, that's done. This has to have a nice decent radius on this edge. I'm not going to do that yet because I'll use that top lip to touch off with the grooving tool. This diameter here is 60.98 for a length of 17 mm up to this shoulder. It's actually 16.9 from this shoulder. I measured it 4 times and got the same answer. So. $16.98, done well. This groove here is 57.9 mm diameter and it's 9.8 mm wide. So 3 mm blade. Once I go in, I've already got the diameter set off this diameter. Once I go into 57.9, then I'll move across 6.8. I'm wondering whether I should put tailstock support in there, because if it does grab, It's not going to be pretty. Try a bit of coolant. I'll give that a bit more of a polish up. Turn that screen pump off. Going on to the centre groove now. That one there's good. Okay, this next groove is 47.5mm diameter, 6.4mm wide. So we'll have a crack at doing that one. Okay, this one here is 57.9 in diameter, and the width is 9.8 again. Okay, that's it, journaling. This here has to be reduced in diameter, and then it's got to have this recess put in here. Just wondering what the best way is to break these inside shoulders. I am tempted just to put a 45 on them using threading tool. Just tape it around a bit and just break the edges gently. Bit of a fiddle around with some emery and we'll be right. Now I've got to try and hold that somehow and face this off and put that little shoulder on there. Okay, now I've got to put that little recess in, and looking at it, it's not much of a recess, so I'm just going to eyeball this one. Yeah, nice. I'll clean all this up and then be over to the mill. There's our piston. Did put a tiny little mark on from the jaws there, but I'm not too concerned about that. That turned out pretty neat. There's not much machining to do, so that's why I've just gone with these aluminium V-blocks sitting on a parallel. You can see what I've got to do there, these two flats. So I'm just going to gingerly take my time. It's got to go down to this ledge and into this lip, this top lip up here. And then I've just got to put these two set screws. And they're not 90 degrees apart, these. I don't know if that's for a reason or just the way they've done it. I really don't know. I'll try and get a bit extra light. Really got to do something about lighting. How's that? Nice. That's that side done. I'll hop over the other side and do that one. That'll do it. Probably going to get done up with a pair of Stilsons or a big shifter and probably mark it anyway. While that's in there, I'll just nick along that with a file off camera. That don't look too bad, eh? Certainly do. So now all I've got left is, where are they? Put the 2 set screws in. That's not bad. And M5 these have got to be. That is that one done. Now I'll rotate it around, and I was looking at this one. What that one there is in the middle of these 2 flats. This one here is basically in line with the edge of that jigger here, so I'm just going to do the same. All done. Bloody ripper. Clean it all up, get rid of a little burr inside that internal thread, and we're good to go. Pretty stoked about that. Little bits of burr in there I'll have to get rid of, but I'll work on that. Well, I hope you all enjoyed that video. That was fun to do that, to make that piston, because I'd never made one before. And at the same time I did renew this rod. Yeah, if you go back through the videos, I've already shown that before when I done me mate Cole's one off his tractor. I renewed the rod in that. This one was really easy. It was only a matter of threading one end, getting it the right length with a spigot on the other, and welding the eye back on. Here's going to replace this spherical bearing. That's why I didn't bother pulling the bearing out when I welded it up. And I'm sure next time he pulls it apart, he's never going to forget about the 2 set screws under the seal. Anyway, appreciate your watching, and I'll see you on the next one. Hooroo.